Welcome to SysTechs. In this practical machine learning tutorial, we will train a gastric cancer detection model from scratch using the Kaggle dataset on a high-performance computing cluster. Let's get started. Let's begin by logging into the cluster using RemMina. Windows users can use the WinSCP and PuTTY. Open RemMina on your system. Press the plus sign to create a new profile. In the name field, enter a user-friendly connection name, such as CFD-cluster-SSH. In the group field, type HPC cluster. In the labels field, type HPC cluster as well. You can name the label as you prefer. From the protocol drop-down list, choose SSH. Enter the hostname as cluster.cfd. Set the port to 52222. Enter your username and password. Save the connection profile by pressing Save. Now, let's create an SFTP account in RemMina for file transfers. Copy the profile you just created. Change the connection name to CFD cluster SFTP. From the protocol drop-down list, select SFTP. Leave the rest of the parameters unchanged and save the connection. Now, connect to the cluster using both the SSH and SFTP profiles. After successfully logging into the cluster using your SSH profile, deactivate any active Conda virtual environment using the following command. Conda deactivate. Now, create a Python virtual environment using pip. 1. Run. Python 3 mvenv. It will take a while, be patient. Once the virtual environment is created, activate it using source -bin/activate. To make the thing permanent, open the .bashrik file, and comment out all the lines related to Conda. At the end of the file append source/min/bin/activate. Hold on the Control key and press X. Save the .bashrik file. At the next login your Python environment will be activated automatically. Right now you can activate this environment by executing source/.bashrik. Next, download the gastric cancer dataset from Kaggle and split it into training, testing, and validation sets. 1. Use Python or a bash script to split it. 60% for training, 20% for testing, 20% for validation. We have already copied the gastric cancer data to your home drive, so you can use it as it is. However, you can also upload data to the cluster from your PC using RemMina or WinSCP. Let's upload the data and Python code to the cluster. 1. Use your SFTP connection in RemMina if you are a Linux user, WinSCP if you are a Windows user. 2. Transfer the dataset and Python scripts to the appropriate directory on the cluster. Next, generate a requirements.txt file using piprex. 1. Navigate to your Python project directory. 2. Run piprex. Force to create the requirements.txt file. Activate your Python virtual environment. Run source/min/bin/activate. Install dependencies from the requirements.txt file. 1. Run pip install our requirements.txt inside your virtual environment. Create a shell script to execute the code on 2 GPUs. 1. Open a new file named run_script.sh. 2. Add the necessary commands to load modules and run the Python script with GPU support. I am using this script to submit my job. 3. Save and close the file. Open the Python code and make the required changes to meet your computing environment requirements. Submit the job using Spatch. 1. Run Spatch run_script.sh to submit the job. Monitor the job status. 1. Check the job queue using skew. 2. Use tail fxyzerror.log and tail fxyzout.log to monitor logs. SSH into the node where the job is running. 1. Identify the node from the skew output. Under the Nautilus column, you can see the name of the node where the job is running. To access the node, if you are not using PDSH, run bash SSH node name. Check GPU utilization. 1. Run NVIDIA to monitor GPU usage and confirm that the job is running on both GPUs. Log out from the cluster. Once you are satisfied with the job submission. 1. Run exit to disconnect from the node. 2. Run exit again to log out from the cluster. Retrieve the results after job completion. Wait for the job to complete. Once it is finished, you can access the cluster and download the results. 1. Use SFTP to retrieve the trained model, graphs, and log files. 2. Store them securely for analysis. This concludes our process for training a gastric cancer detection model on an HPC cluster using the Kaggle dataset. You can review the results at your convenience. See you in the next tutorial.